Most manufacturing investigations do not start slowly. They usually start with a clear signal. A defect spike. A yield drop. A deviation. A recurring downtime event. A batch that suddenly behaves differently than expected. The slow part comes after the signal. It is the process of finding the evidence, connecting the evidence, and getting the right people aligned around what actually changed. Imagine a quality engineer walking in on Monday morning. They see that surface scratches on line 3 increased over the last 24 hours. At first, this sounds like a simple question. Why did surface scratches increase? But in manufacturing, a simple question can quickly turn into a cross-system investigation. The MES may show the production history and lot genealogy. The QMS may show nonconformances or prior kappas. The CMMS may show a recent maintenance event. The historian may show pressure, temperature, vibration, alarms, or tool conditions. Supplier records may point to a specific material batch. And the shift supervisor may know something that never made it into a formal system. So the problem is not that the data does not exist. The problem is that the evidence lives everywhere. This is where investigation time disappears. Someone has to pull the report. Someone else has to validate the timestamps. Another person has to confirm whether the lot IDs match across systems. Maintenance has to check what changed on the equipment. Quality has to check whether the issue has happened before. Engineering has to determine whether the process window shifted. By the time the team has enough evidence to discuss root cause, hours, sometimes days, may have already passed. And in regulated or high-complexity manufacturing, that delay matters. It can mean more scrap, more rework, delayed release, more lots exposed to the same issue, or a slower response to a customer or auditor. The bottleneck is not always root cause analysis itself. The bottleneck is the time spent finding, joining, and trusting the evidence. In medtech, slow investigations can delay EDHR review, non-conformance closure, or kappa containment. In pharma, they can extend deviation investigations and batch release. In semiconductor, they can allow yield drift to continue across more lots. In electronics or battery manufacturing, they can turn a small quality signal into a larger scrap or rework problem. Different industries, but the same pain pattern. Dashboards are still useful. They help teams monitor performance. They show trends. They track OEE, yield, downtime, and quality metrics. But dashboards are usually built around questions you already knew to ask. Investigations are different. They often start with a question that crosses systems, functions, and time. That is why many teams still end up exporting data, emailing screenshots, and scheduling meetings, even after investing in digital systems. The systems are digital. The investigation workflow is still manual. This is where AI agents become useful. Not as hype. Not as autonomous decision makers. And not as a replacement for quality engineers, process engineers, or manufacturing leaders. The practical role of an AI agent is to shorten the path from signal to credible evidence. Instead of asking a quality engineer to manually search 5 or 6 systems, an agent can help ask, what changed before the defect spike? Which lots were affected? Was there a tool change, maintenance event, or parameter drift? Is one supplier batch overrepresented? Did this happen on one shift, one line, or one product family? Are similar issues hiding in prior nonconformances or kappas? The value is not that the agent magically declares root cause. The value is that it narrows the investigation and shows the evidence behind each likely contributor. For regulated manufacturers, this distinction is critical. AI cannot be a black box that makes quality decisions without oversight. A useful manufacturing agent must be governed. That means the recommendations are traceable. The sources are visible. The human remains in the loop. Access is controlled by role. And the workflow supports quality, compliance, and audit expectations. The goal is not to remove accountability. The goal is to give accountable people better evidence, faster. In medtech, the investigation question may be, which devices, components, operators, equipment, and quality records are connected to this nonconformance? Here, faster evidence correlation can support EDHR review, genealogy, containment, and kappa evidence. In pharma, the question may be, what changed before this deviation? Which batch records, lab results, equipment events, or prior deviations matter? Here, the value is not just speed. It is getting to the right evidence while preserving traceability. In semiconductor, the question may be, Which tools, recipes, metrology results, or supplier lots correlate with this yield drop? In electronics or battery manufacturing, it may be. Which process step, material batch, or equipment condition is creating repeat scrap? Different environments. Same underlying issue, fragmented evidence slows decisions. The use case changes by industry, but the pain pattern stays the same. The right starting point is not a massive AI transformation program. Start with one investigation workflow, one line, one product family, one recurring issue, or one high-friction quality process. Define the systems involved. Define what evidence the agent is allowed to retrieve. Define how recommendations are reviewed. Define what success looks like. For example, reduce time to first credible hypothesis. Reduce manual report pulling. Improve containment speed. Shorten deviation or non-conformance review. Help engineers identify likely contributors before the next shift. That is the 90-day roadmap mindset. Do not start with AI for everything. Start with the investigation that costs your team the most time. Think thin slice pilot, not big bang transformation. Because in modern manufacturing, investigation speed is becoming a competitive advantage. Move from manual report hunting to governed, AI-assisted investigation workflows.